a certain number of tabs, but for things that are longer than a tab, you might need to do something like take 20 times the length of the string and multiply that by the space character, so we get this many spaces added on to that particular element, so that we get the right number of spaces after that printed element. We'll go over more nicer ways to handle fancy string formatting tomorrow. But as you can see here, this will print it out in a much nicer format. To sort by departure time requires a bit more coding. We need to first, one way to do this is to loop through and build up a new list that you sort manually. There are fancier ways, again, of doing this sorting, but we haven't gone over those techniques yet. So what I've done here is just start a new list, just grabbing the first element of the flights list, and then loop through each remaining element in the list and compare it to the elements of our sorted list. Grabbing the time element in the current tuple and seeing how it compares to the time elements of all the tuples we've already looked at. So I won't describe every aspect of this, but you can look at this code later. But this is just going through each element of the flight list and comparing the departure time to the flights already added to the time-ordered flights list. And we print the same as before. Oops. And verifying. Did not run this. And there we see that the list is now sorted by time. And I've added a couple extra things to this if you want to look at more fancier solutions to doing this. You can do something using the module operator to sort in one line instead of looping through every single element. You can do this, which will do the same kind of sorting technique. So this is the single line that you need to do to sort it by the fourth element in that array. So there are ways to do the sorting in a more elegant way. So this will give us the same answer. And there are also more elegant ways to do printing, which we'll go over more tomorrow. But this is a much smaller and easier to define way of getting exactly the number of spaces that you want after each element. Cool. Any questions? Yes? Is this available anywhere besides here? I can't read that. Yeah, you can download this solution and go through the notebook on the schedule. It's not on the schedule. It's not up yet, but it will be up there. It should be. I thought I saved it. I'm sorry. Let me see.
I got it into refresh. Clear your browser cache. It's there.
Yeah, it's there. Okay, any other questions? Okay, cool.
Yeah,
where's Fernando? Okay.
You want to talk about the IPython notebook introduction?
I am probably the worst person to talk about the IPython notebook. Yeah, I'll go find Fernando.
There he is.
All right.
Let's see if this thing behaves. We were having some issues yesterday. Okay, it looks like that's working. Hi, everyone. My name is Fernando Perez. For those of you who don't know me, I was in the other room, in the overflow room. And what we're going to talk about now is a little bit more about a more detailed introduction to IPython, which you guys have already seen some of it. It's a tool that began as my thesis procrastination project many years ago, back when I was a grad student in particle physics. And today it's a fairly large project that multiple people develop, and we have a team here working at Berkeley on the development of IPython for various aspects of scientific computing. And are you guys okay with the audio and everything? Okay. And so let's see if I got the one thing that I'm a little unsure about is that I got the links right here. So let me see if if my links made that. Okay, yes they did. And supposedly I uploaded file. Okay. So in here I've added the 3 notebooks that I'm going to be covering, links to them so that you can view them online. But if you want to actually download all the files, there's a link down here to a zip file that has everything that I'll be using, so that you guys can download it, unpack it, if you want to follow that way. But you can also just look at them through these links that should open in the notebook viewer for you. And so let me. Let me start by telling you a little bit what this is going to take a second to load. It's a big notebook and the network isn't exactly the fastest. At least we've been having some problems in the morning with the network. I don't know if it's gotten better. Okay, here we go. So let me try to give an idea of what IPython is. It's a tool that you guys are going to be using a lot. Louder? Louder, okay. It's a tool that you guys are going to be using a lot. So the word the name was born as a shorthand for interactive Python, because it started as a way of providing a better interactive interpreter than the default one that you guys have already seen in the morning with the three little greater sign prompts. And it has grown into a fairly complicated platform to interact, still kind of in the spirit of having a shell where you can type your code and see your results, but now it's a fairly complex collection of tools, but around the same idea, to give you a way of interacting with your code and your data. And this web notebook system that we've been using and that you guys have already seen some of is something that we have been calling a system for literate computing. How many people in the room have ever heard the term literate programming? A handful, okay. So literate programming is a term that was introduced in computer science to describe the notion that instead of writing computer programs only for the computer, you should write them for humans. And they developed tools that would allow you to basically write narrative and write a program together, and then so that you could create either a document that was meant for human readability or a document that would be a program for the computer to run from the same original sources. The idea being that if you kept the explanation together with the code, it would lead both to better explanations of the code and possibly to better code as well, because you were explaining it carefully as you wrote it. And that model has been worked on for a number of years. In IPython, we've taken that idea with a twist with the notebook environment, which is we don't call it literate programming, but literate computing, because the idea is to still give you tools to mix code with text and narratives, but also with the results of the code right there. So the focus here is on computing. You run some code and you get a figure and you're thinking about the figure and you write something about it, or you write an explanation of what you're doing. So the idea is that now that the computer has become such a central part of scientific research, we should be able to communicate our scientific ideas and our scientific narratives together with the computational component of those narratives, and have that be in a way that can be used by ourselves as a better environment to do our work, but also as a way of sharing, of collaborating with others, and of reproducing our own research results later on. And in addition to that, IPython provides also tools for parallel computing. And this may sound a little bit odd or unusual at first, but there's actually a reason behind it. The idea is that once you start typing code and you have tools to control one programming environment, say Python, and give it code to run and get results back, the notion of doing parallel computing is actually doing the same thing, but instead of doing it with one, doing it with many. And so we've built a system to basically abstract out many common operations in parallel computing. So at first, let's have a quick look at IPython at the terminal. This is something that you guys have already seen. I have a lot of material to cover, and since I saw that Josh already went over some of this, I'm not going to repeat it. But you guys have already seen that if you type IPython at your terminal, you get something that looks like this. The colors may be different, but basically you get something like that, and then you can type code and the results come out. This happens at the terminal. We will, on the third day, we'll come back a little bit to more in-depth uses of other pieces of IPython, but for now I'm going to stay in the notebook because I actually think that as a starting point, it's an easier environment for less advanced uses. It's still very useful to have the terminal system because often that's all you have. And so knowing how to operate, or sometimes you just need a quick calculation. You want to run a quick script. You want to just plot something real quick and don't even need to save it. You just want to look at your data. So the terminal obviously starts much quicker, and it's still good to have it. But for now, we're going to stay in the notebook environment. In terms of giving you guys ideas on resources, there is 2 books. The landscape of book resources for Python has gotten better in the last few years for scientists. There's always been a great many books for programming Python, but they were mostly aimed at software developers or web programmers. But for us scientists, there weren't. Now there are 2 fantastic ones. The first one that I want to mention is this book. I only have 1 copy, but if somebody wants to have a look at it, I'm happy to lend it to you, which is a short book that it's called Learning IPython for Interactive Computing and Data Visualization. It's not just about IPython. It actually introduces IPython, NumPy, Matplotlib, and Pandas. Basically, the tools we're going to be introducing today are all covered here in a very, very quick and summary fashion. And then there's a second book that I'll talk a little bit more later about, which is this other one that we'll cover in the afternoon, later in the afternoon. That is a much more in-depth book that focuses on the Pandas libraries. And the author of this book will be speaking here tomorrow at our industry panel. He works at a startup in the city. But this book is if you want something that's kind of organized in book format, I strongly recommend this as a nice quick read that covers the basics of a lot of what we're doing in this workshop in sort of a nice and concise format. And I think they have a Kindle edition for it too if you prefer to read it on an iPad or a Kindle. In this notebook, there are links to several other resources. In case you guys need help with IPython, we have on the website, there's videos and extensive documentation. If you search for IPython in depth, you'll find a 3-hour video tutorial with all of the accompanying materials that you can watch that goes into a lot of depth on IPython. You can ask questions on Stack Overflow, which is a website about questions. We have a mailing list. On GitHub, which is the website where we do our development, you can file bug reports. You can ask on Twitter. We have a Twitter feed. And on the Reddit social site, there's actually a subreddit dedicated to IPython maintained by a community member. And one important resource that I want to point out is this website called the Notebook Gallery. Did it open or did it not open? Yeah, it's opening. So the Notebook Gallery is in our wiki. And I strongly recommend that you guys have a look at it. It's basically a collection of notebooks that we have found online that people have published about many, many things, right? And some of these things are actually there's even entire books that are being published as collections of IPython notebooks. So this one that I'm opening right now is a really impressive book that is published. The entire book is being published as a collection of IPython notebooks, which means that you can go. It's specifically on Bayesian methods for statistical analysis. And if you go and read these notebooks, they are actually it takes a little while to load. Let me give the math a chance to render. It is a complete book with mathematics, with text, with explanations, with code, with figures on Bayesian statistics, and you can read the whole book. You can download the book, you can contribute to the book, and you can execute the book. So as you're reading it, you can run each example, you can recreate the figures, you can change them, you can tweak them. So you have books that are completely 100% executable that are being now created with these tools. And there's a growing collection. This first section is a section of every link in here is an entire, either a book or at least a collection of related notebooks on a topic. And if you scroll down, there are now single notebooks on many topics. There are notebooks on pandas, this library that we'll talk about more, on analysis of social data of all kinds, from public health data to gun violence, to NFL data, to the Gaza-Israel crisis. I mean, so you will find, and each one of these things, whenever you click on each one of these things, let's click on this one, on the NFL. Did I click on it? Oh, yeah, here. Each one of these things, when you click on it, takes you to the full notebook, which you can view. And this is hosted on a website that we maintain called Notebook Viewer. So the Notebook Viewer is a service that we provide, we meaning the IPython project provides, that basically renders any notebook which is available anywhere on the internet. So if you put your notebook somewhere online, wherever it is, as long as it could be on your website, on your campus account, on Dropbox with a public link, on GitHub, anywhere you want, and you paste the URL of that notebook, this service will automatically render it and generate an HTML rendered version of it so that other people can see the rendered version without having to install IPython. And whenever you render one of these, there's a download link at the top here for you to download that notebook. So we basically provide a service that makes it very easy to collaborate and share work in the form of notebooks with others. So if you create an annotated discussion of a topic, of a problem you're working on, and you want to share it with colleagues, as long as you're willing to make it public, all you have to do is put it in the internet and give them that link. And then they can automatically see it. And if they want to, they can download it. Okay? So I strongly recommend that you guys sort of browse that gallery a little bit. I'm not going to spend more time on it. It's, as you saw, it's pretty big. There's all kinds of stuff. But there's a lot that you can learn in there, and every one of those is a resource that you can use to teach yourself something or to use as a starting point for some other work. Okay, so IPython goes beyond the Python language, and you've already seen hints of that before with Josh. But let's see how do you use IPython inside of the notebook. So in order to run code in IPython, let me make this big. Is that big enough for the people in the back to see, by the way? Is that comfortable? Okay. And you can follow also along with the links that I posted on the schedule. So the main key for now that you need to know about is that you hit Shift-Enter to execute any bit of code. So if I am here and I hit Shift-Enter, it runs that block of code. If I put hello and I hit Shift-Enter, it runs that block of code. So what IPython gives you at the most basic is like a terminal, but a terminal where instead of being in a terminal environment, you have these little blocks, and each one of these little areas, we call them a cell, allows you to type code, and when you're done with it, you hit Shift-Enter, and it executes the code and gives it to you immediately. So how do you get help? One of the things that we're not going to be here to teach you for the rest of your research careers on a day in, day out basis, so we need you to be as self-sufficient as possible. When you're working alone, how do you get help? In IPython, use the question mark operator, and Josh already mentioned this. When you type question mark with IPython, if you type only question mark, you get this little introduction to the system that presents, and this will work whether you're in the notebook or in the terminal. If you're in the notebook, it shows it here at the bottom on this pager, which you can close here from the little X bar or by clicking on the divider here. And it basically summarizes what IPython is. But the question mark can be used for many other things. For example, if you have an object. Here I've loaded a module called collections from the Python standard library, and I know that the collections module has something called a name tuple, and I want to know how to use it. All I have to do is type collections name tuple question mark, and then IPython will basically try to find out about what name tuple is and show me information. It's showing me something called the docstring of the name tuple. The docstring is a string that explains how to use name tuple. And so it's a little summary of what the name tuple thing does. And if it's a function, if you're when you write your own code, you want to add these docstrings to your own code, and we'll learn how to do that, because it means that whenever you need to figure out how to use it, all you have to do is put a question mark, and then you can get your little summary information back. Okay? Now, you can actually put 2 question marks. If you put 2 question marks, IPython will try to dig deeper into the object. So a single question mark gives you an overview of the object. A double question mark, it'll attempt to dig deeper. Depending on what happens, the information you get with 2 question marks may be the same that you get with only 1. It doesn't always succeed in digging deeper. But if it does succeed, it'll do things like finding the source code for that object and showing you the source code. So in this case, I asked for a counter, which is another element, another object contained in the collections module, and IPython is actually showing me the entire source code of how the counter object is implemented. So you can actually learn a lot by simply reading the source code, or figure out how to use something if it's poorly documented by simply putting 2 question marks and just looking at the source code right there while you're working. And then you can copy and paste something from the source code and keep working yourself. So it's a very handy way of digging rapidly into objects that you're trying to understand. Okay? And then, there is, whoops, got a little. You can also use the question mark to search as a wildcard search. Imagine that you wanted to know what are all the things that have the word int in them. Because maybe I want to try to do something that I want to try to call a function that I imagine has the word int, but I don't know if int is at the beginning or at the end, and I want to find out what things have the word int in them. You can use question mark asterisks like search wildcards, and then ask a question mark. And in this format, the question mark will just search in all of the available names and tell you what things are available that have in this case, the 3 letters int in the namespace. So this is a very useful way of finding out quickly things when you don't even know how they are spelled out. And finally, if you want to, so I'm sort of giving you all of the little tools at your fingertips for understanding how to use the system. Once you're kind of familiar with the various things that IPython can do, if you want to quip mnemonic, you can type quickref, %quickref. %quickref is a command that calls up a quick reference card. It's a cheat sheet. It just calls up a cheat sheet that summarizes many of the things that I'll talk about for the next hour are basically summarized here in one single list that you can read and remind yourself of what the system does. So one more very useful thing that IPython does for you, which I think Josh already mentioned, is the tab key. Tab completion is an extremely useful part of using the language interactively because it lets you discover things. First of all, it saves a lot of typing. And second, it lets you discover lots of things about what is in a system. For example, if I want to see what is available in this collections thing that I loaded from the Python library, all I have to do is say collections.tab, and it will show me everything that's available, and I can then select one of these. If I type a few letters, then it will automatically only show me whatever comes after what I have typed so far. And this actually, you will be surprised about how much effort we've put in IPython into making the system very robust, because in practice, once you get used to it, it's extraordinarily useful to have the tab completion, especially because it completes on everything from numpy, imp, port, random, right? As I was typing, it was completing keywords, it was completing modules that I can import, it was completing inside of that module, what can I access, it will complete file names in your file system, it will complete arguments in function calls, it basically constantly helps you trying to figure out what should be available next for you and shows it to you. Okay, so these are kind of the various things that you should know as you're working to save you time. While you're doing computations in IPython will display these results, and it actually saves those results. So whenever you've returned a result, that result is available as the variable underscore, which is very handy if you just computed something and you want to refer to it, but maybe it took 2 minutes to compute, and you forgot to save it as a variable. You can access it just with underscore automatically. That variable is always there. You can prevent that from happening if you put a semicolon at the end. Then you will prevent the output from being returned if that's what you want, which helps sometimes. There are libraries that actually you want to call them because they do something for you, but they return some additional thing that you don't want to see. We added this because it actually is a common case. You'll see often when you're doing plotting, matplotlib returns all these internal pieces of information when what you're really after are the figures. So you're trying to get a figure, but you're getting are available as 1, 2, and 3 underscores just for convenience. And similarly, the input history is similarly available. So instead of out, you have in for the input history, and underscore I as the last 3. So it gives you a way of accessing things that you've typed before. What's very useful, especially at the terminal, is the command, the %history command, that gives you the ability to see your history. So you can say, show me my history, print me line numbers, and show me lines 1 through 5 of what I've typed. Or you can say, just show me my history. This is everything that I've typed so far in this session. So sometimes you want to say, show me what I've been typing for a while because I want to copy and paste that into a file or whatever. The history command helps you control everything that you've typed. You can see the history with inputs, with outputs, etc. Now, one thing that IPython, and I want to note for those of you who are on Windows, the actual commands that I'm typing here may not work exactly on Windows because the syntax is different. I see a lot of Macs, so this applies only to a few of you. But the basic idea works on Windows. It's just that the name of the commands on Windows is different from the name of the commands on a Mac. On Linux and Macs, these commands exist. Whenever you type anything and you prepend an exclamation mark at the beginning of the line, the rest of that line goes to the operating system. So instead of being executed as Python code, it's whatever the underlying operating system does. So it's a very useful tool to have while you're working in Python. You don't have to go to another terminal to run some other command. You can put your commands right in here inside of the IPython shell. So this is where IPython begins to go beyond the Python language. Python doesn't let you do this. If you wanted to do pwd in Python, you would have to go and find what is the library in Python that tells me what the working directory is. It turns out there is one. You have to import OS and this and that. In IPython, we tried to make it really easy to say, if you need to access the operating system, just put exclamation, type whatever you need. It happens immediately. And in fact, you can actually grab the output of commands. And this begins to come in very handy. Imagine that you want to grab the output of running the ls commands that lists files. So this is, I've assigned the value of the ls command to the variable files. And now I can print, these are the file in my current directory. Okay? And now, furthermore, look at what you can do. You can now run a command, and then in that command, replace the Python variable files with the value of that variable as a string. So basically, we've allowed you to do this weird, bizarre, a little mind-bending hybrid of capturing commands from the shell and then running Python and then running back other commands with the values generated from the Python code. And that can be very, very, very handy. I can never for the life of me remember how to do a complicated loop and a complicated piece of logic in Bash, but I do know what command I want to call. So I do the complicated looping in Python, and then I just make the command call that I need in Python. And you can do, for example, here, I can echo. With $, you can replace a variable. If you put braces, you can put an arbitrary Python expression in the shell command. So I can say echo the first file in files and call it, that was an old result from a previous run. The first file in my files list and call the upper method that uppercases the name, but do that at the shell. So these kinds of things are actually very, very handy when doing complicated file management. If you don't want to do it all in Bash, you can simply do most of it in Python and do the bits and pieces that you want by calling out your commands in Bash. So this is a little unholy, and system purists find it a bit obnoxious, but in practice, I can tell you it's extraordinarily useful. So IPython, it goes beyond Python in multiple ways. And yes, question.
Is there a way to check the return code of system calls that you make using the bang syntax that you just described?
No. So the question was, I'm repeating it for the overflow room. The question was, is there a way to check the return code of a system call made with the bang syntax automatically? And the answer is no. As far as I can remember, we don't save that like $? Does it in the shell, for example. We don't have the last return code. I guess that's not a bad idea. Would be to basically add a global that would be that last return, because we can get it. We just don't save it. So yeah, that could be your first contribution to IPython. So any other questions right now? Feel free to interrupt me at any time. So the next way in which IPython goes beyond Python is something called magic functions. And you've already seen me type a few of these things. There are these commands where I put % at the beginning. That's not valid Python syntax. And you've seen that we type things like quick ref or other things at the beginning of the line. What does that mean? Well, these are special commands that are basically, that serve two purposes. On the one hand, they're a completely new set of names that don't collide at all with your Python variables. So they give us a command language, basically, to do things in IPython that are unrelated to whatever happens to be going on with your own code. We could obviously, in IPython, have given you a bunch of Python functions to operate, to manage IPython itself and to do useful things, but then we would have the danger that anytime you load or define your own variables in your environment, then they would be probably colliding with our own names, and you would be constantly prevented from using them, or we'd have to make them have really long and annoying names like IPython-this, IPython-that. So instead what we did was, there's this extra system of commands that all begin with a %, and they're completely separate from your Python variable. So whatever is a command with a % is independent of the other names. And these commands, furthermore, you can define your own. So you can extend this list of magic commands. You can define your own magics to do whatever you want. Number two, they are called much more like command line functions without argument, without parentheses, without quotes, without commas. They're simply % command spaces and arguments. So they're just a lot more convenient for interactive typing than making function calls. And we found them to be very, very useful, and we're going to see a few of these magic systems. If you simply type magic, what IPython will do is it'll open the same pager as before, and it'll tell you a lot more detail about the magic system, including examples and so on and so forth, so that you can read about it in excruciating detail. As always, by the way, if I wanted to know how magic was implemented, what would I do? Go ahead. Double question mark. So if I didn't lie to you guys, there we go. This is the actual implementation of the magic call itself. This is the source code for magic. This is how magic is implemented inside of IPython. And it shows you actually where, in what file that is implemented. So where in the file system that is, in case you want to go and open it with a text editor. So magics, there's all kinds of magics that exist in the system. When you type %magic at the bottom, it gives you basically a long, detailed description of all of them. One of the most widely used ones is %timeit. What %timeit does is it executes the code that comes after it, but very carefully profiles it to give you really accurate timing information. So if you want to know how much a given snippet of code takes to run, you can use %timeit, and IPython will run it. But magics can carry 1% sign or 2% signs. When they carry 1% sign, we call them line magics. They apply to whatever's on the rest of the current line, okay? when they carry 2% signs, this syntax can only be at the very beginning of the cell. But when they carry 2% signs, they apply to the entire cell. So they let you do something, and they let you do whatever special operation you want with the body of that cell. Each magic can define whatever it wants to do with the content of the cell. In this case, the time it magic, when applied to the whole cell, will actually do the same thing as the single line one. It'll time the execution of the whole cell. And line magics can actually be used anywhere you want inside of a block. So just like I did in the other block, I did files equals %ls. You can call, because this is invalid Python syntax, then you can do this, and basically we translate it for you into the real underlying Python syntax. And so in this case, if I run this block of code, I'm actually running an operation in a loop, and each time I'm calling the timeIt function, and it will do the time operation on that piece of code. And as you see, it provides the timing information. One thing that you can see here is that depending on how fast the loop is, it runs them different amounts of times. So timeIt itself is self-adaptive, basically, so that obviously if you give it an expensive piece of code, it won't try to run it 100,000 times and make you wait for a year. What it does is it runs it once and gets a rough idea of how long it takes. If a single run already took 20 seconds, well, that's the time it'll give you. If it takes microseconds, then it calibrates and loops many times to give you accurate timing information. Okay? So the magic system, it turns out that there's a massive machinery, a massive amount of machinery that we've built around the magic system to do all kinds of interesting and crazy things. For example, calling other completely different languages. We have a magic called $bash. When you start a cell with $bash, it means the code in there is syntax for the bash shell. It doesn't run in Python at all. The Python magic will take the bash magic, which is written by us in IPython, will take that block of code and call bash with it and let it execute, which means you can copy and paste inside of a notebook that document that does a certain amount of work. If you need to call a complicated piece of shell scripting that you had written before, you can just paste it right there, and you put $bash at the top, and it'll execute as part of your notebook workflow, calling out to bash for everything that you want to do. So in this case, I run this, and it echoes my shell is bin bash, and it called the free command that prints the memory status of this computer right now. Okay? So this is one that I believe you guys have already used, which is the $file. And what this one does is it simply writes the contents of the cell to a file with a name that you want to give it. And so it's sort of a poor man's text editor inside of the notebook if you want to create other files. The reason why this can be handy is because, as you can imagine, since the notebook runs through a web browser, you can be running the notebook on a remote machine that you don't have otherwise access to. But if you need to create a local file in that system, you can do it with the file magic. Or if you have a notebook which for some reason you want to create a little bit of code, a little bit of a text file or a CSV file or something small because you need some other program to run and find it in the file system, it's a convenient way of basically embedding snippets that you want written out to the file system for you. So if I now run this command, it shows me this. If I edit this file again, and now I run this again, any content that I put in here shows up there. Every time I run, it's completely destructive, right? That it is meant to actually overwrite the content of that file with this data. There are many magics. I don't have time to go over all of them. As always, you can ask question mark about any one of them. And we have extensions to IPython that ship other magics. Not every magic is preloaded in the system. You can actually load sort of plug-in type components that add new functionality so that if you use R a lot, it turns out there's a magic to call out R inside of IPython. If you use Octave a lot, there's a magic to call Octave inside of IPython. We'll talk later about Cython, which is a tool to speed up Python code by emitting equivalent C code that can run much faster. We have a magic so that you can put Cython code right inside of your notebooks. And this system is extremely useful because it is customizable. If this list was only whatever we wrote, it wouldn't be that interesting. But the value, I think the value of it is that we have an API for you to define your own magics that can do whatever you want. How am I doing on time? schedule. I forgot to bring the printed schedule here. Adam or Chris, do you guys?
4 minutes.
Ooh. Okay, that's not enough. Okay. Well, no, but actually, I do have a little bit more than that in the sense that we're not going to have an explanation for the breakout, because the breakout in this case, the solution, the breakout for IPython is mostly to try and use it and play with it and kind of become familiar with it. There's no code to write. There's no real solution to work on. It's mostly just learning how to use the system. So I'm going to eat up basically another 15 minutes off over the normal time. One thing that we do is that we let you paste code straight with the prompts from a standard shell or even from an IPython terminal shell, and we will actually run it correctly for you. Basically, we strip out all of this leading stuff out of the way so that if you have code that you found somewhere online, you can just paste it right in and it'll execute correctly. When your code produces errors, so let me write a file here that creates an error that could call an error if I call it with the wrong argument. So I wrote this file mod, and if I load and I call the g function with 0, g calls f with y plus 1, and f returns 1 over x minus 1. And I did that kind of slightly convoluted just so that I could show you what errors look like in Python. So because this is an important part of programming a language is understanding how errors are displayed and learning how to read errors. So when you cause an error, what you get is called a stack trace, and IPython prints this stack trace or traceback with a fair amount of detail, much more detail than the default Python interpreter. The way you read these errors is from the bottom back up. So the error here is a zero division error. Errors have a type, and the zero division error was caused by this line because that's where the error happened, right? But that line was caused by this line, which is when we got the call for f because f was called by g, and g was called by us at line 2 of this right here. So in IPython, we try to print these with a fair amount of context so that it's easier for you to read, and we also allow you to change how much information you see about an error. So the Xmode magic changes how exceptions are displayed. So if you change to what's called a plain exception type, you get something that looks a lot more like what Python itself shows. So if this error, if you were not using IPython, you would see something like this, which as you see has a lot less information. It doesn't have the highlights, it doesn't have all the code around, it's just the line where each error occurred. This is how plain Python shows exceptions. And the reason why it's useful to have that is if you ever want to copy and paste this into a tutorial for someone else and you don't want to show any of the fancy IPython stuff, you can use it. And we also have a verbose exception mode. And verbose exceptions, if you look here, what they do is they actually show you the values of all the variables that were called at that point. So this is not the default mode because it can be expensive to compute all that extra information, so we didn't want to make it the default, but it can be very handy. If you have a weird error and you don't understand why it's happening, you can just say exception verbose and run your code that way, and then you'll get a lot more data about what's happening at each frame as your code is called, because often what happens is you call something that you think is right, but 3 or 4 or 5 levels deep, something happens with that code, that variable, there's an off by 1 error somewhere, you pass the wrong information, and the error, things blow up deep inside. But it's not the data that you passed, it's something that was changed from the data that you passed. And so seeing those layers of additional data can be a huge time saver. And so it's important that you know how to turn it on. So this X mode magic lets you toggle between plain, verbose, and what we called, whoops, what happened here? Context. Context is what we call the default exception mode. So this was already mentioned, so I'm going to skip it. The fact that in the notebook you can type raw input, and you will get in the notebook, This only works if you have version 1.0 because it supports direct input. If not, if you don't have version 1.0 of the notebook, you can do this in the terminal where it does work normally. If you type %debug, this will give you an interactive debugger. So whenever an error has occurred, in this case I caused an error by calling again mod g of 0, and I got my error. What if I want to understand what happened? If simply looking at the code doesn't tell me what happened, I can type %debug after an error occurred, and %debug gives me the Python interactive debugger. The Python interactive debugger, called PDB, and we put an I in there because we've added some IPython fanciness to it, is a system that was designed for debugging code. It's a fairly primitive system, but once you get used to it, it's actually not bad. It has commands. If you type question mark, it'll tell you what the commands are. For example, list L, short for list, prints the code around where you are in the stack. Up goes up 1 frame in the stack. Down goes back 1 frame. So it lets you move. An error occurred. I have all of these layers of code that were called, and now I can go inspecting what's happening at each of these layers. So I can say, oh, let me go back. I don't understand why this happened. Let me go back 1 frame. Oh, here in G, I want to see what the value of Y is. If you do exclamation, you can pass normal Python code. Just like in IPython, exclamation takes you to the operating system. In the debugger, exclamation takes you from the debugger to the Python language. That's kind of the mapping. And so, oh, Y is equal to 0. Let me go back down again. What is X here? X is equal to 1. Ah, okay, so now I understand. And what is X minus 1? It's 0. You can evaluate expressions with your variables. Obviously, this looks silly, but imagine that instead of X minus 1, you had a nasty, complicated 7-term expression in there, and something in that expression was blowing up, and you have no idea which term. You can go in the debugger and say, print this term, print this term, print this term, until you see which one is the one that has maybe the weird off by 1 error, rather than trying to guess in a complicated algebraic formula which of all of the pieces of the formula is producing an error. Okay? So as you do scientific programming, you will spend a lot more of your life debugging code than you will spend it writing code or getting interesting results. That's just life programming. And so learning how to debug is a very important skill. And knowing that this tool is available there and becoming proficient with it can save you enormous amounts of time. Okay? And to quit the debugger, you type Q, and then you're back into normal IPython. If we were at the terminal, we would be back at the normal prompt. As I said, this only works in the current version of the notebook. It took some elaborate effort to make this work inside of a web browser. So, and it's not completely pretty. It's not the prettiest thing. It's not perfect. But hey, it gets the job done. Any questions? Okay. So very quickly, the notebook also lets you plot. So if you type %pylab inline, what IPython will do is it will load the Python plotting libraries inside of the notebook. Depending on what you have, you may or may not see this error message. Ignore it for now. It's a warning. It's not an error. And what this does, now I'm going to load the numerical and plotting libraries. So what this does is it lets me actually kind of hook together plotting and the web browser so that they cooperate together. And then I'm actually going to load the plotting libraries. And we're going to cover this in more detail, but I want to show you one of the things that basically how roughly it works. And later in the afternoon, we'll come back to this in detail. But the basic idea is you can type your commands, and when you make your plots, your figures show up right here immediately in line. And these figures get saved. When I save this notebook file, they get saved. And so the notebooks that I was showing you earlier, for example, from that book, this is what they had. They had plotting blocks that were producing figures that were saved in the notebook. And the actual image is embedded in the notebook file so that when somebody else opens it, they can view them right there. Obviously, the execution is not there. If you want to actually recreate the figure, you have to rerun the code. But the image, the snapshot of the figure is saved into the notebook. Okay, let me skip this one. Can somebody remind me of the time? I know that I'm over the original time, and when was the end of the? When was the beginning of the explanations?
You wanted to end at 1:45.
That's when we start the next one.
You wanted to give 15 minutes for the breakout, right?
Yes, but without time for the solutions.
So that'd be at 1:55.
Solutions are from 2 to 2.
You should end at 1:45.
Solutions are from 2 to 2:10? Okay, no, but I'm not going to do solutions.
So the next lecture will start at 2:10.
Exactly, that was my question. Okay, thank you. The next lecture starts at 2:10, okay. So, because in this case, all of the exercises are basically play with the interface, play with the notebook. There's no code to be written, so we don't really have solutions to explain, in a sense. So, I think I'll run probably until 50. Okay, so now I'm going to switch to, so were there any questions? So this is an overview of the things IPython does that go beyond the language. Since Josh already covered the language itself in the morning, I didn't go over any of that, because basically everything that Python does, you can do it inside of the notebook or inside of the IPython terminal or whatever, because IPython is a strict superset of the language. So the things I was explaining are all the weird things that IPython does that go beyond the language. And all of these things have been added to IPython to make your everyday life as a scientific programmer as easy and convenient as possible and as effective as possible. So now let me go back to the notebook itself. Now I'm going to look in a little bit more detail at the notebook. So what are in the notebook? When you start the notebook, this is what you get. We call this part of the notebook, we call it the dashboard. Let's ignore for a minute this clusters thing here. We'll revisit that on Wednesday. What it shows you are the notebook files that are in the current directory. Unfortunately, the current version of the notebook is hard-coded to the path where it begins. So if you want to run a notebook, 2 notebooks in a different place, you have to start 2 of them. Fortunately, the way it works is the notebook will open up in a new port each time, so you can actually run as many as you want. It doesn't matter. They keep picking new numbers up here. It can get a little confusing, and we're fixing that. We know it's annoying, but that's the way it's currently implemented. So you get in the dashboard, you get here the path where you started it, and you get the current files. You can start new notebooks in here, and you get the files that are currently listed. And the notebooks themselves are just files with an extension of IPyNB on your file system. You start the notebook by simply typing IPython notebook where you want to start it, which you saw already this morning. And what does a notebook file look like? A notebook file is actually a data structure in a format called JSON, which stands for JavaScript Object Notation. And in here, we actually have code in IPython. In the IPython library, we have code that lets you read the notebook as a data structure to operate on it. So you can actually manipulate these files as data structures. And this is really important because we've written a fairly elaborate amount of machinery to take notebooks and do things with them. Like say you want to export the code that is contained in a notebook. Say you want to take a notebook and produce a web page out of it. You'd want to take a notebook and export it to LaTeX in the format of the American Physical Society. All of these things can be done because what we have here is a data structure where we have the input you typed, the output it produced, the figures that came out. So we can take a notebook and disassemble it into HTML with figures in a subdirectory with the correct LaTeX generated for PDFs, et cetera, et cetera. So it is a complete data structure is what's in there. And what the notebook allows you to do is to embed, when you write code, it produces output. But you've seen me showing lots of text that was not code. That code, that information is written in a format called Markdown. Markdown is a format that was written to make it easier to write HTML. So it's a superset of HTML that allows you to do certain things with a more convenient syntax. So for example, in here, I have put stars for a bullet list. And when I get out of this cell, those stars become a proper bullet list, right? If I have, I can put LaTeX, I can put arbitrary HTML, I can put images. The notebooks themselves can be put under version control. We're going to talk about version control. Jared, is that tomorrow?
Yes.
tomorrow we're going to talk about version control. And so you can put your notebooks, they're just normal files, and we've made attempts to make them as friendly to being put on version control systems as possible. And as I showed you already, you can view them with this NB Viewer service. You can also produce just the Python code that's in a notebook. You can either say, give me the notebook downloaded as a py script from this menu, or if you start the notebook with -- script, every time you save a notebook, a corresponding .py is auto-generated so that you have both the fancy viewable version and the pure py script file together as you work. So the user interface of the notebook is it's a web application. These days, these things are pretty common, like Gmail, like anything else. Basically, what we've done is we've put menus, etc., inside of the web browser, just like you would in any other web app. The dashboard contains the file list. If you want to upload, this is a heading 2 cell. By putting our own heading control, then we let you do things like create automatic HTML anchors for the levels, which let you link in between sections of different notebooks. We will eventually add things like give me an outline of the notebook, like a table of contents of the notebook. And we can do that very easily if we have a notion of levels. If you put your own HTML headings by hand, it will look the same, but we won't have knowledge of that structure, so we can't do these kinds of structural operations on it. And then finally, the notebook has a lot of keyboard shortcuts. I've been mostly using the mouse in here to move around and to show you what the menus are, but the notebook actually has a lot of keyboard shortcuts, okay? And I strongly recommend if you start using it regularly to get familiar with the keyboard shortcuts, because as you work a lot, it's much more efficient to operate with key bindings. Shift-Enter is the one that we've been using mostly to execute every cell of code. If you want to execute a cell and insert a cell right after this one, use Alt-Enter instead. But then we have a bunch of other key bindings, all of which begin with Control-M. So it's Control-M and then a key. You will probably end up memorizing the ones that you use most often. This is how these things work. You don't have to memorize them all. They're always there in a menu. You go to Help, and you ask for keyboard shortcuts, and they're all there. The reason why they're prefixed in this weird manner, Control-M and then something, is because we have to work across all the web browsers and all the operating systems. If you can imagine the notion of having keyword shortcuts that don't conflict between Chrome, Firefox, Safari, and Internet Explorer on Linux, Mac, and Windows, it's impossible. So what happened is we found that Control-M was not used by anyone, so we made Control-M a prefix, and then we have our own key bindings afterwards. It's kind of a ghetto solution, but there's no other way. With all the browsers fighting for control of the keyboard, it was the only sensible thing we could do. Okay, so the UI, for anyone who's used to something like Gmail, hopefully the user interface of this is fairly familiar, is fairly kind of intuitive and easy to absorb. The buttons have tooltips in them, but always keep in mind the notion that you're working with this thing on cells. When you're inside of a cell and you're editing it, this works like a normal text editor. You can do cut, copy, paste, all that inside of a cell. I can copy here, paste, 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 etc. I can undo with Control-Z. It's like a little word processor in there. But when you're outside, you're operating at the whole cell level. So for example, this right here will copy a cell, and this will paste the whole cell below. I can paste the cell above, below, or paste on top by replacing. I can merge and split entire cells. So a lot of the operations of the notebook are really thought at the cell level. That's kind of the atomic unit that the data structure operates on. And then finally, let's have a very quick look at, and I'll stop at 50 so that you have time to basically play with the system, at putting a more complex Markdown. So Markdown, as I said, is a syntax. So this is the other notebook that's in here. Markdown is a syntax, an extension to HTML that was defined by this fellow whose website is called there in Fireball. And many people have adopted it because it's basically, it looks like plain text, but it contains HTML. So what it does is many things that you would do in HTML, you can do much more simply in Markdown in this way. So if you want italics, you just put text between stars, and that's italic. You want boldface, you put 2 stars, and that's boldface. And when you get out of the cell, it becomes italic or boldface. You can do bullet lists just like this, and you can do nested bullet lists by simply indenting more, right? You can do numbered lists, and it actually automatically numbers. So for example, you can do this, and Markdown will automatically do the numbering for you and do the nested numbering, because it knows that means it's a numbered list. It doesn't matter what the actual values are. It's treating it as a proper HTML numbered list, which means it's, and actually in general I recommend doing this, numbering everything just with a 1. That way you're telling it that it's a numbered list, but if you insert new things, it doesn't matter, they get renumbered correctly. You can add horizontal rules. If you simply put 3 dashes, you get a horizontal rule. You can add block quotes. So if you're quoting email or things like that, it actually is properly quoted. The link syntax is much easier to remember than the syntax for links in HTML. You just put in brackets the text and in parentheses the link, rather than having to remember href, quotes and all that, and source and target and all that. Headings can be done with hash marks, 1, 2, 3, etc. N hashes mean heading of level N. As I said, though, we strongly recommend that you use our heading level so that you can get the structural benefits of managing the notebook. You can embed source code. So if you simply indent 4 spaces, it will assume that it's source code, and it will actually syntax highlight it. And you can even put code inside of lists if you indent further. So this is actually placing code that is ready for copy and paste right here. And it detected that this was Python, and it detected that this was C, and correctly highlighted both languages. And very, very usefully, you can put mathematics, arbitrary mathematics. So if you put single $signs, we render that equation inline. And if you put double $signs, we render that equation as a displayed equation using a library called MathJax that basically implements all of the LaTeX rendering algorithms in pure JavaScript and provides the the LaTeX fonts. But remember that Markdown is a superset of HTML. So whenever you don't know how to do something in Markdown, you can always copy the underlying HTML and it'll work correctly. So this is, for example, a raw HTML. Files / it will actually, the web server that runs the notebook will display it as part of the HTML. The reason why we need this extra prefix has to do with the way the web server that runs all of this application is architected. So there's this kind of extra quirk that if you want to refer to files in your HTML sources so that the server renders them, you have to prefix them with files /. But then you can access local files that have anything, such as, for example, embedded video. So this is a valid, animation M4V is a valid video file using HTML video, and I can embed it, and this is actually an embedded animation that is inside of the notebook. So you can create documents that have text, that have mathematics, that have code, that has images, video, animation, anything that you can put in the website, you can put in here, together with the code that produces results, and share these documents. So this gives you sort of a pretty complete, I know it's super fast, but it's a fairly comprehensive overview of what the entire notebook machinery, well, not all of it, but some of what the IPython machinery from the core language to the notebook system can do. And so now we're going to give you, up until the next one, as I said, we're not going to have solutions for this one, because the exercises are really about you practicing. So it's basically practice downloading and adding notebooks, practice using the key bindings, practice familiarizing yourselves with the user interface, practice in the Markdown cells file. There's also a few little exercises in there. So try to practice these various these various operations for about 10 minutes. And importantly, ask me or ask any of the TAs if you have any questions, if something doesn't make sense, if something isn't working for you. As you saw from the demo, people are doing fairly complex and elaborate things with the system. They're writing entire books with it. It's a really powerful environment. We're here to help you use it. So try to play with it, try to kind of familiarize yourselves with it, and ask us if you have any questions. And then we'll continue. I can't remember what the next. What's that? At 2:10?
It is functions and modules.
Functions and modules in about 17, 20 minutes. Steps. Some of you, let me explain the problem that Carlos just had, because there's a good chance somebody else is going to have the same problem. So for the exercises, don't right-click on this and try to download that exercises notebook, because the web server that serves this website on Google Code, on Google, will do the wrong thing automatically. It'll give you nonsense. What you want to do is click on it so that you see it, and either you can look at it on the screen or click here on Download Notebook. And that will give you the correct file. Because if you try to download it from here with Save As, I don't know what the web server does. It gives you some complete notsense file.
Cool. So once I've opened it, I just download.
Yeah, download Notebook.
That's awesome. Thank you.
Mm-hmm. Yeah.
My notebook still is not.
Did you try again running that command?
I deleted the whole thing. I uninstalled everything. I did try installing the command, and I got some kind of errors.
Okay. So you uninstalled
I
Anaconda completely
yes.
and reinstalled it?
Yes.
And same mess?
Same thing.
What the hell? Well, let's try. Yeah, question.
we're going to get started in about 3 more minutes, okay? I have some another movie to play. Yeah, so just.
Now, my good man, some cheese, please.
Yes, certainly, sir. What would you like?
Well, how about a little red Leicester?
I'm afraid we're fresh out of Red Leicester, sir.
Never mind. How are you on Tilsit?
Never at the end of the week, sir. Always get it fresh first thing on Monday.
Tish tish. No matter. Well, 4 ounces of Caerphilly then, if you please, stout yeoman.
Ah, well, it's been on order for 2 weeks, sir. I was expecting it this morning.
Yes, it's not my day, is it? Bell Pay, is it?
Sorry.
Red Windsor?
Normally, sir, yes. But today the van broke down.
Stilton?
Sorry.
Gruyere, Emmental?
No.
Any Norwegian Jarlsberger?
No.
Liptar?
No.
Lancashire?
No.
White Stilton?
No.
Danish Blue?
No.
Double Gloucester?
No.
Cheshire?
No.
Any Dorset Blue Vinny?
No.
Brie, Roquefort, Pont-l'Evêque, Port-Salut, Savoyard, Saint-Paul, Carré de l'Est, Boursin, Brest-Bleu, Pelle de Champagne, Camembert.
Ah, we do have some camembert.
You do? Excellent.
It's a bit runny, sir.
Oh, I like it runny.
Well, as a matter of fact, it's very runny, sir.
No matter, no matter. Hand over la fromage de la belle France qui s'appelle Camembert, s'il vous plaît.
I think it's runnier than you like it, sir.
I don't care how excrementally runny it is. Hand it over with all speed.
Yes, sir. Oh!
What?
The cat's eaten it.
Has he?
She, sir.
Gouda?
No.
Edam?
No.
Caithness?
No.
Smoked Austrian?
No.
Sage Derby?
No, sir.
You do have some cheese, do you?
Oh, certainly, sir. It's a cheese shop, sir. We've got...
No, don't tell me. I'm keen to guess.
Fair enough.
Wensleydale?
Yes, sir.
Splendid! Well, I'll have some of that then, please.
Oh, I'm sorry, sir. I thought you were referring to me. Mr. Wensleydale.
Gorgonzola?
No.
Parmesan?
No.
Mozzarella?
No.
Pippo creme?
No.
Any Danish Finbo?
No.
Czechoslovakian sheep's milk cheese?
No.
Venezuelan beaver cheese?
Not today, sir, no.
Well, let's keep it simple. How about cheddar?
Well, I'm afraid we don't get much call for it round these parts, sir.
It's the single most popular cheese in the world.
Not round these parts, sir.
And pray, what is the most popular cheese round these parts?
Ilchester, sir.
I see.
Yes, sir, it's quite staggeringly popular in the manor, Squire.
Is it?
Yes, sir, it's our #1 seller.
Is it?
Yes, sir.
Ilchester, eh?
Right.
Okay, I'm game. Have you got any? He asked, expecting the answer no.
I'll have a look, sir. No.
It's not much of a cheese shop, really, is it?
Finest in the district, sir.
And what leads you to that conclusion?
Well, it's so clean.
Well, it's certainly uncontaminated by cheese.
You haven't asked me about Limburger, sir.
Is it worth it?
Could be.
Okay. Have you got... Will you shut that bloody dancing up?
I told you so.
Have you got any Limburger?
No.
No, that figures. No, it's pretty predictable, really. It was an act of pure optimism to pose the question in the first place. Tell me something. Do you have any cheese at all?
Yes, sir.
Now, I'm going to ask you that question once more. And if you say no, I'm going to shoot you through the head. Now, do you have any cheese at all?
No.
All right. Welcome back. So we're going to take a step back from IPython and get back to some of the important things in the core language of Python itself, and that's functions and modules. You've already been exposed to functions and modules throughout the morning, but now we'll sort of give you an explicit tutorial on that. Okay, so Python can be considered both so-called procedural, and that is using functions, and it can be considered object-oriented. Right now, I'm mostly going to be talking to you about the procedural aspects of Python. Tomorrow, we're going to do objects and some more sort of complex function stuff. But for now, I think this should suffice as a lecture in and of itself. Okay, so functions look like the following. They have the important three letters DEF in front of them, and that defines the function. And then it has a function name, which I've put here in blue. And then it has a series of so-called arguments separated by commas, arg1, arg2, etc. And you can call those anything you want. When you assign an argument as you're calling this function, those will become variables that are now available to whatever's inside of that function. In addition to arguments, there are these things called keywords. And like we saw with dictionaries, we have a keyword and a value, a keyword and a value. Arguments are required, and the order in which they're presented and given as somebody is calling this function is also fixed by the way that you define them. So if you have function name, comma x, comma y, comma z, if you're calling that function from somewhere else, you better be sure that that first argument that you're giving it is what you want to be called x inside of that function. When you have keywords, those are considered optional. And so typically what you'll wind up doing is set, say, keyword. If I wanted to say cheese type, I could say equal to none, or I could say equal to Jarlsberger. And if you don't give, when you're calling that function, cheese type equals, then you will basically use the default as that variable. So in the end, arg1, arg2, keyword 1, keyword 2 will become objects/variables that are available to the function once it's running. So arguments are required, keywords are optional. You can name your function anything you want as long as it contains only numbers, letters, and an underscore. It does not start with a number. And it is not the same as a built-in function like print. It's actually not true, that last thing. You can create a function which is called print. You probably would want to call it something like myprint to avoid what's called namespace confusion. But if you create a new function and it's already been defined, so say print, print's not a good one because that's kind of a strange, let's call it pow, right, which is raising something to the power. You, by all means, can go ahead and do that, but you're effectively overriding a built-in function. So just be very careful about that. You typically want to be, and this is in general good coding practice across languages, you want to be building up function names that sort of have some meaning but aren't conflicting with others. There is no difference between functions and procedures. Unlike in, say, IDL, in Python, functions that return nothing still return something, and that something is called a none. So if you have a procedure which winds up doing something, but then and maybe takes actions upon some variables and prints something out and sends an email to you, you might not want it to do anything when it comes back. When you don't return anything, the actual explicit return is something called none, right? If you want to return whatever you want to return, you will basically wind up using a return statement, as we'll see. Any questions about naming, about arguments, about keywords? Okay. So let's take a look. You can fire up your browser in IPython, and you can type this in, or you can do this within Python or within IPython in the terminal. So let's create our first function, def space add nums, so you can guess from the name of this what this is going to do. And I have 2 keywords or 2 arguments? 2 arguments, x and y, and you notice I put a colon at the end, so it's as if I'm creating a new block. And this is going to do something very simple. It's going to return x plus y. Okay? So if you run that with 2, 3, I get back what I expect. That's good. What if I want to add 2 numbers, and here's some octal representation of some number. I guess it's a hex representation. 1f, comma 3.3. So on the left-hand side, I have some sort of int. On the right-hand side, I have some sort of float. And it does something sensible, right? Because Python's interpreting the left-hand argument as some sort of integer, and the right-hand side is a float. And as we saw at the beginning in the morning, you get back a sensible answer that is a float. So we can guess what 1f actually is. That's probably 31. Oh, so let's add 2 other things. Let's add a plus b, the strings a plus b. What do you think we get back? ab. And why is that? It's because strings know how to concatenate themselves. They understand what it means to do a plus, right, with respect to each other. We saw that earlier on. So even though I called my function addNums because of this strange sort of typing issue within Python, if you have 2 objects that know how to add with each other and return something sensible, you will get a result out of this. So what if I want to add nums cat and some other number? I'm going to get some error out of that. Right? Okay, so this is a problem, and it's up to us to figure out how to do some sort of error checking to make sure that our function does what we hope it would. So unlike in C, we can't declare what type of variables are required by the function, so essentially inside that function, we have to make sure that we're getting the variables that we expect. How about using isInstance, right? So if I said, if not is instance of x of a float or an int or a long, or y is not a float, int, or a long, then I might want to return back something. I might want to return back something sensible. Excuse me. So here I'm basically saying I don't know how to add these 2 different types together. Maybe it would have been, we would have said something else, because in this case, if they were both strings, I do know how to add them. I just don't want to do that within my function. And I'll return back. And what am I returning? I'm just returning. So this is effectively procedure. Effectively, whatever's calling this would get back a none. And if I haven't returned, I'll just return an x plus y. So let's see how this does. 2, 3.0, 5. Add nums 1 plus a. I can't add these types. And you see what Python wound up doing in the end is it wound up giving me a none, because that's actually what got returned. Okay? Any questions about what I did? So I did a little bit of error checking, or at least type checking, before I actually went ahead and did what the main function of this function is. Let's talk a little bit about scope. I use this word namespace. I want to help us all understand when I'm using x and y, where is x and y actually valid, and where does it make sense to use x and y? First of all, if I just type the name of the function that I just created, I get something that looks like this. It says function addNums is at some really weird place. this is essentially telling us where it is in memory. And while we very rarely will ever access that memory, it's sometimes useful to understand where these functions live. So this is some sort of little thing that lives inside of a memory buffer that Python is pointing to. Type of addnums, what do you think that is? We saw a little bit of this earlier. It's a function. And remember, if we said type of POW, we got that it's a function that's or a built-in method. So it's a similar type of thing. So let me say x is equal to 2, and then I'll say print addnums, and that should be 11. What do you think x is? Remember, we're using x inside of the function. Is x 5 or is it 2? It's 2. And that's because x only has meaning inside of addnums, and x also has meaning outside of addnums. And even though they're both called x, they're referring to different things. And so when you call a function, the scope that it winds up operating on, all the variables within that function, stay within there. Okay? Python has its own so-called local variables list, and x, unless you're explicit about it, is not modified globally. There is a way to do that, but it's considered pretty poor coding practices to have to do that. So let's create another function. Whoops, excuse me. Let's create another function which we'll call numop, x comma y. And that will multiply x by 3.14, and we'll return the result. So if x is 1, and I print numop of x comma 3, what's the answer? 6.14. If I print x again, I get 1. That's what we expect. We can now actually create a global variable inside here. Will basically redefine numop. X times equals 3.1. We'll declare a new variable which we'll say is global, which means that it has meaning and carries that same meaning outside of the scope of just that one function. We'll add the number 1 to it, and I'm going to return x plus y comma a. So I'm actually going to return a tuple, although I didn't give the parentheses. That's how it will be returned. So let me, outside of that function, say a equals 1. And I'll say numop 1 comma 1. So what's going to wind up happening here? The first argument will be multiplied by 3.14. And then what I'm going to return as the first argument is essentially 3.14 plus 1, which is 4.14. But I'm adding to the value of a. And you notice that I didn't use a anywhere inside of the argument when I made my function declaration, right? Somehow there is this thing that's a, and it's defined elsewhere as viewed by this function. So what am I going to wind up returning? 4.14 comma 2. Because I bumped up the value of a inside of my function. What do you think a is now? Well, first of all, let's look at numop 1.1. And I bumped it up again. So what you notice is that I kept this sort of persistent notion of what a was. And if you were able to print out a, you would see that a has also been incremented also in the top level namespace. The other thing I showed you here is that we've returned not just one answer, I've returned multiple things. In this case, it's just some value comma another value, which basically makes it look like a tuple, and that's pretty nice. One of the things I want to point out as we sort of build out more sophisticated functions is that it's actually pretty useful to think of arguments as the things that are absolutely required, that really define fundamentally what that function's job is. But oftentimes you wind up sort of creating embellishments around that. And it's okay if you're sort of building out the code and realizing over time as you're building out this code what the functions actually are, because we all know that we just don't scope out, all of our code ahead of time. Very, very often we're actually sort of iteratively creating new functions as we wind up learning more things. But here, what I would do is use keywords as a way to sort of add to and augment the returns of a given function that I've been using, say, throughout my workflow. And instead of basically having to break old code, if I add keywords, because these keywords are not are not required, as long as I give these keywords the default values that they would be in the legacy version of the code, then I will basically get the same result back when I call this same function with old code as I will with the new code, but now I have all this new functionality. That is to say, keywords are a natural way to grow new functionality without breaking old code. Okay, so let's do that. If greetings is not none, then we'll just print greetings. And we'll return x plus y now times a multiplier, right? So it's essentially still doing the same thing as before, but I'm multiplying the result by, in this case, I set the default to be 1.0, so I'm going to get back the same result as I had before. Let's try this. What do you think this is going to do? Num op 1, comma 1.
Thanks for your inquiry, 2.
What's that?
Thanks for your inquiry and then the number 2.
Thanks for your inquiry and the number 2. And you notice I actually got back 2.0 and not the number 2, which is what I had before, so I had a slightly different result, and that's because I multiplied by 1.0. So now I can change my multiplier to be minus 0.5, and I can set my greetings to be none, and I get back minus 1. Okay? Does everyone see how we're using keywords and we're using arguments, and we're using these keywords as basically embellishments on the original functionality of the code? Now this is kind of interesting. I can create a function which we'll call cheese shop, harkening back to the beginning of this lecture and the famous Monty Python cheese shop scene, with these special things where I have a star arg or double star keywords. And what's nice about this is both arguments and keywords are now considered optional. And the only thing that's required in me calling this function cheese shop is a variable called kind. And I can give an arbitrary number of arguments after I've set kind. And then I can give an arbitrary number of keywords afterwards, and those all wind up getting used. So even though the function doesn't know what you're going to wind up passing it, so we haven't explicitly said, you know, we're going to have 5 keywords and we're going to have 7 arguments. Sometimes when I call this, I could call it with 5 arguments. Sometimes I could call it with 3, and sometimes I could call it with 10. And this thing will wind up doing what makes sense. So here we can look at this, print, do you have any kind? So that's sort of a cheese. I'm sorry, we're all out of kind. So now we're creating a dialog. For arg and arguments, print arg. So whatever these args are here, right, I'm just going to print directly out. And then I'll have a little line break. And then I'm going to get the keys of these keywords. And what do you think keywords actually is? What type of variable is a keyword? It's a dictionary, right? Because remember, the method on top of dictionaries is keys. And I'll sort those keys, and then I'll basically print out all the results. So let's see how we might call this. So the cheese shop, we're gonna now write something about Limburger cheese. It's very runny, sir. Well, it's very, very runny, sir. So those are my 2 arguments. The shopkeeper is Michael Palin, and the client is John Cleese, and the sketch is the cheese shop sketch. So now when I run this, I basically just created a little part of the dialogue. Do you have any Limburger? I'm sorry, we're all out of Limburger. It's very runny, sir. It's very, very runny, sir. And it tells me a little something about what's in this sketch. If I called this again with a different cheese and I have it a different response, I could set a different number of arguments and a different number of keywords. Okay? What this is actually doing here, this is essentially unpacking the result. So when we send this to cheese shop, everything that is after kind that isn't in this form of keyword, keyword, keyword gets turned into something called arguments. And then when you unpack it, you wind up having essentially a list. And here I'm basically double unpacking keywords, and I get a dictionary out. You won't ever have to do this essentially outside of the context of creating a function of this sort, but it makes a function very, very powerful because in some sense you're doing something in a generic way on a bunch of inputs that you don't know what the inputs are yet. Yes, question?
So arguments and the keywords, as
So arguments, so the question is arguments and keywords, are those different data types? Absolutely. Arguments gets unpacked into a list, which is now something I can iterate over. And what you see that I've done here is I've iterated over each one of the elements in that in those arguments. And then keywords gets unpacked as a dictionary of keyword value, keyword value, keyword value. Yes, so this is when you call it this way, you would wind up unpacking this as a list, and this would get unpacked as a dictionary. Now, if you're doing this not in the context of a function, and for some reason it was very efficient to unpack a variable this way, in principle, if you had a list of tuples, and that list of tuples was called keywords, and I did this double star in front of it, I believe it would unpack it as a dictionary. But that's pretty kludgy, and you'd lose most people reading your code. You should do it more explicitly. Any other questions? Okay, we saw a bit about this when Fernando showed you the doc string when in IPython Notebook you typed something and then you did question mark and you got to see this, the access to the documentation. Documentation is just the right thing to do, and it makes Python really simple to read, especially if it's, I was going to say somebody else's code, but sometimes it's hardest to read our own code from the past. And the nice thing about this is we make it really easy to document your code. And this is what's called a doc string. A doc string is the first unassigned string in a function or a class or a method or a program. Anywhere essentially you have a block that you want to create this doc string. You can do it with triple quotes. You could do it with a single quote. I'm doing it as a triple quote here because I'm going to break across a couple of different lines. And what I have is more or less just a description of what this thing does. Numop1, this does a simple operation on two numbers. We expect x and y are numbers and return x plus y times the multiplier. Multiplier is also a number. A float is preferred and is optional. It defaults to 1.0. You can also specify a small greeting as a string. So you notice I didn't assign this to any variable. I just basically created some string inside of this function. So here's my function. And now I can say help, parentheses, numop1. And what you see is, or numop1 question mark if you're doing what I just did in IPython. Go ahead and create a function, say def space my function, comma x, or parentheses x, colon, create a little string, that's your doc string, have it return something, and then do help, and then the name of your function. Why don't you just try to do that now? Why? So when you run that, you're creating something called, you're running something called PyDoc, which is basically running over Python, or using Python, it's doing the interpreter, and it's creating an output HTML file. And it said, I wrote numop1.html. So let's take a look at what that looks like. And it's actually very pretty. Here's numop1, and actually at the top of that file, you'll see I have another doc string here. It says some functions written to demonstrate a bunch of concepts like modules, import, and command line programming. And you see that I got sort of a nice formatting here. We can see what the inputs are, what the defaults are, and I didn't have to do any extra work. The nice thing here is that if you have multiple Python files in the same directory and they all kind of refer to each other, you can basically automatically create documentation for your entire code base. But you got to write doc strings. And that doc string could be as simple as this does this, or to do write more doc strings. But please start using doc strings. It's a very good coding practice to do it. And we all try to do it as much as we can. Sometimes it's just easier to bang out some code. But if you think there's any chance that that's going to be reused or looked at by anybody else, please just start writing doc strings. It's so easy to do it. You have no excuse anymore. I'm mad at you and I don't even know you. Okay, any questions about that before I move on to so-called modules? All right. So modules, those are organized units written as files which contain function statements and other definitions. We haven't really used this much in the bootcamp so far, but we're going to be using this a whole lot. Any file that ends in the .py file is treated as a so-called module. So numop1.py is a module, and what it does is inside of that module, which is basically just a file for now, I define a function called numop1. This is important in the context of naming. Remember, I said it's really bad practice to create something called a function called print, right? Because we know that's used all over the place, or POW, right? But if you had a module called mySpecialMathFunctions.py and you created a function inside of that which was def POW, and you had something else which basically printed out what power you're raising a number to, then whenever and then I can get access to the function inside of numfun1, which we've called numop1, numfun1 dot numop1, and then I can basically call it as I've called it before. Okay? What if I call numop1 and I just call it the way I just did in the line before? What's going to happen? I have no idea what numop1 is. So why is that? That's because in this function numop1 is only valid in the namespace of this module called numfun1. I haven't imported this capability into my local namespace. So I have to basically go into the namespace, as it's called, of this other module. Is everyone clear on that? So this is nice in the sense that it allows me to organize, where all the functionality is and what the different names are. So I can actually have this all be nested. So I can actually have modules modules inside of modules inside of modules, and at the very end I get a function. So I could have numfun1.myfunctions.numop1, and that's used all the time. The negative of that, of course, is that I don't have direct access to all the functions that I know I'm going to wind up using. Let me give you, again, in the context of namespace and scope, we'll go through a different file, which I've called numfun2. Again, it's in the tarball, in the directory from the website. And I've done everything that I had before in numfun1, except I printed something out. Numfun2 is in the house, x equals 2, s equals spam, spelled incorrectly. So what I'm doing here is I'm doing stuff, and I'm assigning variables. So if I want to get access to this function numop1, what do? Import numfun2. What do you think is going to happen at the end of this statement? Well, everything that's at the top here, because I'm now actually basically creating these functions, but what I'm doing is I'm going through, the interpreter is going through the script and saying, oh, you want me to print something? I'll print something for you. Numfun2 in the house. What happens if I import numfun2 again? Shouldn't I get the same thing back? No. Okay, so this is one of the weird things in Python. It takes a little getting used to. So let me explain what happened. The first time I called import numfun2, I basically ran through this script, right? And I basically ran the print numfun2 in the house. And by the way, I also set the variable x and s. The second time I did it, Python said, hold on, I already know what numfun2 is. It's already in the namespace, and you're asking me to reload it. Why would I do that? That is such a silly thing. You are silly, and I'm not going to do it. So it doesn't actually then rerun the script. Okay? And that's an important thing to recognize. There is a way to essentially force Python to do that, but if you try to import something that's already in your namespace, Python will refuse. So if I print numfun2.x and numfun2.s, these are not functions, right? These are basically variables that are associated with this module. And what do you think I get? 2 in spam. If I set s is equal to eggs and I print s and I print numops2.s, what do you think? Calling module name dot something. What I can do is say from module name import function name, or from module name import variable name. And I can do comma, 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 comma. I can just say don't pull in, let's say this is a huge file and it's called my math functions, and all you really need is access to your new POW function. You can just explicitly pull in the POW function, and Python will try to go through and not actually import the rest of all the functionality into that namespace. So let's do this. From numfun2, import x comma numop1. So I've pulled in one of the variables and I've pulled in the function. It runs, it says print numfun2 in the house. X is equal to 2. Do you think this is right? Yes. So what did it do? It pulled x into my current namespace, even though that x was actually originally defined inside the namespace of numfun2. Numop2, comma 3, comma 2, blah, blah, blah. Do you think that makes sense? Yes, because now it's in my namespace. Right? I went into the module and I said import it into my namespace so I have that access. I'm not doing module name dot numop1 anymore. So that's very handy, right? What do you think S is? I have no idea what you're talking about because I haven't imported it into my namespace. What do you think numfun2.x is? What is numfun2? Now look, when I did this at the top, I didn't actually import numfun2. Right? So numfun2 itself is not in my namespace. Only x and numop1 are. Let's say we don't like s because s is such a sillily named variable and we should have named it something more sensible, and your best friend handed you this code and you're like, I'm not going to use it because s is a dumb variable. So why don't we just rename it on the fly? So I can import from numfun2 s, but I want to import it as something else. So in my namespace, I'd rather call this my fave food. I can import numfun2, numop1 from numfun2 as wicked awesome adder. So I can call anything I want. It's still got the same functionality, or it's still the same variable. And I can print my favorite food, which is spam. And I can access my awesome adder, and I get back the answer I'm expecting. Was there a question over here? No. Okay. Everyone see what I've done? I basically, if you have this functionality and it's got a name, I can just basically call it something else if I'd like. You could redefine, if you'd like, you could import from math, you could import the sine function and call it cosine. That probably will get you into trouble someday, so don't do that, but you can do it. Now here's the thing that's actually pretty useful, although it's considered also bad coding practice. This is called kitchen sinking it. You could say from module import star. And what that says is take all the stuff, the variables and all the functionality in the module and just import it directly into my namespace. So from numfun2 import star, now I have numop1 directly in my namespace, and I have s in my namespace, I have x in my namespace, and I didn't have to explicitly call out each one of those things. When inside of IPython you type %sign pylab, that's a way of getting plotting functionality within the IPython notebook, for instance. What you actually do is, besides a whole bunch of stuff on the back end, you're basically pulling everything from something called numpy and everything from matplotlib, which are two very important modules that you'll hear about in the next lecture. You pull all of that into your namespace. And so even though it really pollutes your namespace, it means you can just type plot and you can start plotting something immediately. You don't have to say from matplotlib import pyplot as plot or whatever. Okay? So it's convenient inside the interpreter, but it's considered bad coding style. And that's because it pollutes your namespace. There are a lot of built-in modules, right? And we've really been talking about some of the core built-in components of the Python language. But your entire namespace as you start up the Python interpreter is actually pretty clean. You don't have access to a whole bunch of stuff that you might want to use. There's a whole bunch of things related to the system, Maybe you want to make a system call, a whole bunch of things related to the operating system. There's a whole bunch of interesting math and math constants. Python gives you, when you actually download some of the core interpreters, like what we did with Anaconda, gives you access to a whole bunch of built-ins that you have to now import into your namespace to make use of. So on the command line, if you type import sys, and if you're within Python, you could say import sys, and then on the next line say sys dot, and then press the tab, and you'll see a whole bunch of things that you can do with the sys module. And you can try it with a whole bunch of other types of modules. If you can do this within Python, and you do it within really just the native thing that you download off the web from one of the core Python distributions, you import math, you can be reasonably assured that every single one of those modules is incredibly battle tested and usually fairly optimized to run very quickly. And so if you import math.cos, and you want to get the cosine of a number, chances are it's not some really silly way of creating a cosine out of a number. It's actually doing something that a lot of people have looked at for a long time. Stuff inside of the core Python libraries are heavily battle tested. And while they obviously have bugs, those bugs tend to be sort of on the periphery. Anything at the system or math level is quite robust, and so you can trust it. Yes?
Is there any way you can see the individual functions and variables inside a module?
Can you see any of the individual functions or variables inside of a module? Yeah, so that is a bit of the exploration that one has to do. Either you say, oh, I need something that has to do with like adding times or subtracting date times, right? So what's the difference between, March 30th, 1982 and, January 1st, 1970? I can do that math, but how do I keep track of, leap seconds? There is a module called datetime. And what you wind up learning in Python is that there's a lot of the stuff that you'd want to be able to do. Somebody has probably already written a package, and there's a good chance it's already a core built into Python. So what you can do is get help on all of these things. So I can say import sys, and then I can say essentially help parentheses sys. That will work. If you're in Python again, you could say sys question mark or sys dot question mark, and you'll pull up a whole bunch of things that are available to you. And what are we looking at here? We're looking at a form of a docstring of the sys module. And it gives you basically a nice distinct statement about all the things that are available to you. There's also wonderful documentation. If you go to python.org and you go to the documentation link, you'll see all of this stuff out there very well, and you can search for it. So let's try a couple of things here with modules. We'll start actually using some useful modules for sort of getting access to the underlying OS. So let's import OS. Let's import sys, and you can try this on the command line if you like. And we can make a new function called getInfo, and we'll create a keyword, which is path. And the path is just the local path, or the current path I'm in. It's the current directory, and that's a dot. That's a succinct way of doing that in a POSIX system. I believe this also works in Windows, but I'm not 100% sure. So here's my little docstring. What is this for? Well, it makes use of the simple OS and sys modules, input path, the directory you want to list. This is a pretty bad docstring because I actually just said what I use. I don't say what it actually does. But the code's pretty simple, so we can just parse that through ourselves. Print, you are using Python version something, and remember I have that comma there. It doesn't actually put a new line. Print sys.version. Sys.version is a variable that's associated with every single Python interpreter that ships. And then I can have a little line after that, and I can say files in this directory, os.path.abspath of the path. So here I've basically gone into two different modules. So in.os is my top-level module, and inside of that is something called path. And inside of path is something called obspath. Obspath is a function, abspath, that gives me the absolute path of whatever it is that I've given it. So if I give it a dot, dot will wind up resolving to the current path that I'm in. I can show that off. Go back over here, or not. Here are the photos I took all of you and I put on the web already, on the front page. Okay, so IPython, import OS, OS dot, and I hit tab and you see all the things that are available to me. There's a lot of stuff here. What is OS kill? Oh, I guess I have to give it a process ID and then I have to give it a certain signal. That's not a very good docstring. OS sum. Oh wait, no, that's not something. Let's try temp nam. What is that? Returns a unique name for a temporary file. All right, so what did I say I want to do? os.path. And if I just type it, it shows me the location of where that file, or of where that code is. Path, and I wanted to say abs path. Dot. So what does that do? It figures out that dot is actually the absolute path on my file system is in this location right here. And I just knew that there was something called abs path, right? And it takes a little while if you're just starting to use Python to realize that there's a lot of things that you probably want to do. There's a pretty easy way to do it. So what are we making use of in this one code? OS lister returns a dictionary of all the file names in the specified directory. Actually, I'm not sure it's a dictionary. I think it's actually a list. sys.version. That gets a representation of the Python and GCC version, how it was compiled. Whether you compiled it or not, you got an executable. os.path.abspath, we just saw what that does. There are dozens of built-in modules, and if you go to docs.python.org/mod index.html, these are the ones that essentially ship with Python. And so if you're going to be doing a bunch of math, you maybe want to use this. If you're doing a bunch of things related to email, you might want to look at, the MIME tools, which is for, doing MIME attachments inside of email, things like that. And you notice that there's a few things that have been deprecated. Those have typically the functionality of those from those modules have been moved to other modules. I'll let you read this. This is XKCD. They have realized how crazy this is. You're flying, how? And then this person up in the air says, Python. I learned it last night at the boot camp. Everything is so simple. I just said, hello world is just print hello world. I don't know, dynamic typing, white space, this is, yeah. Come join us, programming is fun again. It's a whole new world up here, but how are you flying? I just typed import anti-gravity. That's it. And then he did some LSD or something. It really is as simple as this. One of my own sort of horror stories or war stories from learning Python way back when I didn't have a boot camp like this to teach me was that I realized I had to add and subtract dates and figure out the times at sort of the millisecond level between dates and do this very accurately. And so I built this huge, huge code base that would go off to the web and figure out when all the leap seconds were and blah, blah, blah. And I did all the math, including, the leap years. And then about a year later, I wound up realizing there's a module called datetime that just does all this for you, including time zone support. So if you find yourself kind of building up a lot of functionality that seems pretty generic, there's a good chance somebody else has done that. You want to do this within Python to do the searching, but you may just want to Google, right, and say, Python email how to, and then there'll be like 12 different email modules that you could wind up using. All right, so this is what's actually pretty neat. We've been mostly just thinking of these Python and .py files as something that I execute within Python. So I bring it into my namespace using this thing called import. But when a script is run from the command line, there's a special variable, which has this terrible name, but it's special, called underscore underscore name underscore underscore. And that variable inside the namespace of the Python interpreter is set to the value of underscore underscore main underscore underscore. So this looks a little bit kludgy, but it means that at the bottom of your script, if you want to run this from the command line, you can say if name equals main, then that part will only get executed if you wind up executing that module from the command line itself. And so what does that mean I can do? It means on the first line of that file, if I add this special # exclamation point and then slash user slash bin slash env, or sometimes basically slash bin slash env and then Python, it means that this file itself, even though it looks like a script, can be considered an executable as viewed by the command line. So it means that if I change this, and I believe this works on Unix and Mac, and I don't know if this works on Windows or not. If you do chmod a+ and then the script name, what you're saying is that everybody can execute this script. That's what the X is for, and A is basically all. And now I can just say /script name. And even though I haven't sort of said explicitly anywhere else Python script name or type Python and then say import, this thing and then run something. What's really nice is that I can have a standalone Python script I can hand to somebody, and it's basically an executable that just goes off and does whatever happens inside of that file. For those of you that are used to sort of scripting languages like Perl, this should look reasonably familiar, at least at the top. This is basically telling, when I actually run this from the command line, this first line up here with the # and then the exclamation point, it's telling the command line interpreter, hey, go off and run this whole script using Python. It's a little bit like Bash's version of a magic function. I was called from the command line, and that gets executed. All right, so here's a reasonably long file. Yes?
Do we need to define the function called main in this? Or like just the name equal to main will suffice?
No, so the question was, do we need to explicitly call and create a function called main? No, we don't have to, but it's actually reasonably good coding practice to do so. So typically what you'll see at the very end of a long Python script is it'll say def main, and then it'll have a bunch of arguments, or it'll have no arguments at all, colon, and it'll do all the stuff that you would do if you were expecting to call it from the command line. And then at the end of, at the very end of the file, it would say if __ name equals main. And then instead of doing stuff, you would just call main. So you'd say main parentheses. So you're kind of redirecting stuff up to a function. This is all this stuff that happens under the if statement is technically in the namespace of the interpreter at the very top level. So it's actually somewhat nicer to push it all into the main. That's a good question. Okay, so here's a larger file, and again, you have access to this inside of the tarball. We'll call it modfun.py, and we're basically doing all the stuff that I showed you before. So we already had that functionality called getInfo, but now under __ name, this only gets executed if I run it from the command line. I'm going to say if the length of sysarg1 of sys.argv is equal to 1, I'm going to get info on the current path, and I'm going to show the current version. So what does this do? Well, sys.argv is a list that gets filled up with all of the arguments that you use to call this function from the command line. So if you said Python -o -l -m, and then the name of the thing, I don't know what all those do, but each one of those -os, -ls, -ms would get chunked up, and those would be called different arguments as viewed by the command line. So basically, if I call this thing with no arguments from the command line, then I'm basically just going to show info for the current directory. If it has more than one argument, meaning basically it's things that I want to list out, I can ask the question as I loop through all of those arguments, is this thing that I've gotten, is that a directory? So I use that with ospath.isdir. And you can see in the help for isdir that isdir returns a true if it's a directory, that string, and it returns a false if it's not. And if it's not, then I just say this directory doesn't exist. If it is, then I wind up basically showing the the info. And you notice for show version, if I is equal to 0, so this is the first time I've called it, then show the version. But if it's not equal to 0, then don't show the version number of Python. So this is a nice, cute way of basically listing out a whole bunch of different directories from the command line. So let's try that /modfun.py. You should be able to do this from within the tarball that I gave you, within the directory that's opened up. So cd into that directory if you haven't already, and type ./modfun.py. If it doesn't have the right permissions on it, so it's not considered an executable, you may need to put the word Python before that. So here's what it did. I didn't give it any arguments other than the file itself. It said you are using Python version blah, 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 and here are the files in this directory. If I call it with my spam directory /temp, my spam directory doesn't exist. Whoops, my spam directory doesn't exist. And you notice what it says there. Oops, I don't know why this is happening. And you see what it says, directory my spamdir does not exist, about halfway down from the execution of this. Okay? So we just created like a nice little script that works pretty well on the command line. It is pure Python. And yet it's, I think, reasonably powerful. Are there any questions about that? Okay. So remember when we tried to import numop2 the second time and we didn't actually execute the print statement? This is a little bit annoying because if you're doing a lot of code and you run it and you get back some answer you're not expecting, you're expecting spam, and instead you got eggs, you go, oh man, what's the problem here? And then you go in and you edit your code with your favorite text editor and you save it. Now I want to say, you know, basically import again. That doesn't work, as we saw. But what you can do is explicitly tell, you can explicitly tell Python to reload the module. And that will basically rerun the importation of everything inside of that module. So import OS, OS system cat josh1.py, josh2.py. Cat is just a Unix way of saying print out the contents of. And so, so in josh1.py, I just say import josh2, x equals 1, and josh2 is is just y equals 2. So you see they're kind of referring to each other in different files, which is nice because you don't have to write one sort of mega Python script. Let me import josh1. So what is josh1 going to do when I import it? First, it imports josh2, right? So now I've got x2 in the namespace of josh1. And I've also set y is equal to 2. So what's josh1.josh2.y? Just 2. So josh1 has imported josh2, and we know that there's a variable inside of that, which is 2. Now if I edit josh2, and I show what that looks like, I'll set y is equal to true. Let me reload josh1.josh2. Okay, so I'm explicitly reloading the thing that josh1 has imported, which is this thing called josh2, and I get true. If you had just reloaded josh1, it doesn't cascade through and reloads everything underneath of it. Okay, so you need to be a little bit careful about that. I will say that, and this we'll get into the breakout session now, I will say that there is a way to do this within IPython that's very nice. There is an IPython magic that will allow you to essentially auto-reload. So if you change a file, Python will automatically reload. The other thing you can do, and you've seen this before, is if you type the word run inside of IPython, what that does is it basically runs the script and executes it as if you had just executed from the command line. So if you change a file and you type run again, that will do what you hope it does, which is essentially re-import everything into the namespace. Okay, so are there any questions before we go into the question of the breakout session? Anything from the other rooms that on the HipChat channels? Anything from the internets? YouTube people? I think there's like a 10-second delay, so we can wait. Okay, then I'm not waiting. Sorry, YouTube people. All right, so let's see. What is this breakout session? Really what we want you to do is explore modules. And inside of Python, you can type help, parentheses, the name of the module, or inside of IPython, this is actually much easier. Type the name of the module, question mark, and you'll learn a whole lot about it. Okay, so I want you to create and edit a new file called age.py. So you have to fire up your text editor, start typing stuff, save it as age.py. And within age.py, I want you to import the datetime module. Now, this gets interesting in terms of the workflow of like how you're kind of exploring and building new code when you have access to a text editor, and you also do this in IPython. Typically, I will write little code snippets inside of IPython, and I will use IPython's ability to sort of do introspection on everything with question marks and double question marks to kind of learn about the functionality and gain confidence in it. And once I've got it, I'll just copy and paste it over into a text editor and then use it inside of my file. So learn about the datetime module. Okay, you can either Google it or you can try to use IPython to help you teach yourself about it. So I want you to use the datetime function to create a variable representing the day that you were born. And if you know the minute or the second, that's cool. It's creepy, but cool. Use datetime.now to create a variable representing what time it is now. Subtract the two, and you'll form a new variable, which will be of type datetime time delta object. And I want you to print out that variable. So this is basically how old you are. How many days have you been alive and for how many hours? So you have to figure out what gets returned inside of this time delta object, and you'll have to do a little bit of math. What will the date be in 1,000 days from now? So you'll want to make use of a time delta object. And last, create and edit a new file called age1.py, and when run from the command line with one argument, age1.py should print out the date in days from now. Yeah, and if run with 3 arguments, print out the time in days since then. So if I say age1.py 1,000, I'll get the date in 1,000 days from now, which is, I don't know if that's right or not, I assume it is. If I print out instead 1981-8, I want to now get the number of days since then. Okay? So you're going to make use of the if name equals main. You're going to make use of the datetime module. And go for it.